Fossil fuels were the energy source that shaped the 19th and 20th century civilization, and now we're greatly dependent on them. In fact, almost 90% of the world's energy currently comes from non-renewable and rapidly depleting fossil deposits. And almost uncontrolled population growth, together with raised standards of living and industrialization, will inevitably increase global energy consumption. And by the end of the century, the energy demand is predicted to triple. To add to the dilemma, the burning of coal, oil, and natural gas has released enough greenhouse gases, especially carbon dioxide, to seriously disrupt atmospheric balance. This gave rise to a well-known phenomenon, global warming. In the face of rising energy need and the threat of climate change, the need to seek a sustainable way to provide sufficient energy for the world is more urgent than ever. Renewables were largely developed in the past decades and still are. However, can they provide reliable energy on the large scale? An unprecedented challenge looms over humanity today. How can we meet humanity's growing energy needs, and how can we do so without destroying the environment? The answer: nuclear fusion. Fusion is the energy that powers the stars and our sun. Years of research have led to the discovery that fusion on Earth is at least theoretically possible. But is it practical? That is the role of the project ITER, or International Thermonuclear Experimental Reactor. ITER is a full-scale experimental device that aims to demonstrate the scientific and technological feasibility of fusion energy. It is an international collaboration that brings together China, the European Union, India, Japan, Korea, Russia, and the United States, totaling 34 nations with the philosophy that no single country can face the challenge of sustainability alone. Cadarache, France, is the host country. There is much enthusiasm about this project, as fusion is expected to become an important part of the energy mix of the future.
Future.
Fusion.
Energy.
Environment. ITER.
Future.
Fusion. Energy. Environment.
ITER.
Fusion works on the principle that energy can be released by forcing together light atomic nuclei rather than by splitting heavy nuclei, as in the case of the fission reactions that drive existing nuclear power stations. If you can force light nuclei close enough together, the strong nuclear force will overcome the electric force that would otherwise repel them. In the core of the Sun, tremendous gravitational pressure allows this to happen at temperatures of around 10 million Kelvin. No reactor on Earth can achieve the high pressures of the Sun's interior. Such pressures have been achieved only in thermonuclear bombs. To compensate for the lesser pressure, temperatures much higher than the Sun's have to be reached. Temperatures above 100 million Kelvin. No materials on Earth could withstand direct contact with such heat. To achieve fusion, therefore, scientists have devised a reactor called tokamak, in which a superheated gas, or plasma, is held and squeezed inside an intense donut-shaped magnetic field. In ITER, several heating methods will work concurrently to bring the plasma in the core of the machine up to 150 million kelvins. The changing magnetic fields that are used to control the plasma produce a heating effect through a process called ohmic heating. Then, neutral beam injection and high-frequency electromagnetic waves will complement ohmic heating to bring the ITER plasma to temperature. The best fuel for fusion comprises two isotopes of hydrogen, deuterium and tritium. The fusion of these two nuclei produces helium-4 and a high-energy neutron. The neutron carries most of the energy created. Since it is a neutral particle, it will escape the plasma and hit the walls of the tokamak. The idea is then that these neutron crashes heat up the walls, which can then transfer the heat to water on the other side, producing steam that will move turbines to produce electricity. Producing high-energy neutrons is the key here, as they provide a simple way to extract heat from the plasma. Fusion has many potential attractions. If ITER is successful, the project could open the way to a new source of power, one that is arguably safer and cleaner than nuclear fission and less problematic than fossil fuels when it comes to the issue of global warming. ITER will produce minimal quantities of nuclear waste. No radioactive products are produced by the fusion reaction itself. However, the neutrons produced by the fusion reactions will activate the materials used in the tokamak walls of ITER. But one of the project's tasks will be to find the materials that best withstand this bombardment. This could result in waste materials that are safe to handle in a relatively modest timescale, compared with the much longer-lived radioactive waste produced as a direct result of splitting atoms in fission reactions. ITER is inherently safe. It cannot go out of control. In case of a malfunction, the plasma would hit inner sides of the tokamak and cool down very quickly, and fusion reactions would halt. Unlike the burning of fossil fuels, fusion reactions produce no carbon dioxide. The fuel for fusion reactions, deuterium and tritium, are readily available and virtually inexhaustible. Deuterium can be derived from water, which is abundant and available everywhere. Tritium can be produced from lithium, which is plentiful in the Earth's crust. The worldwide availability of these materials would eliminate international tensions caused by fuel supply imbalances.
ITER is still at an experimental level, far from being ready. Construction only started in 2010, and the reactor will not be ready to operate before 2019. In fact, a commercial reactor is not expected before 40 to 50 years from today, minimally. The project is expensive, estimated at 10 billion euros, but it promises that it will deliver 10 times the power it consumes, producing large-scale power at low cost on the long term. It seems like fusion has been just decades away for several decades, but ITER will take fusion to the point where industrial and commercial applications become possible. ITER will open the way to safe and environmentally responsible and almost limitless energy.